Okay, so today is a big review day on logs, and then you have a little formative quiz sitting in front of you that you're going to do at the end of the hour. So first off, why do we need logs? I gave you this problem when we started, and I said that's a good reason to know how to do logs, is to solve that when you have an x in the exponent. You can't just like put it to a power. One thing I did say you could do, and only zero, no, one, maybe one person in this room remembered? Remember it now? What could you do? Graph both sides, see where they cross. All right, but without that hack, which would really require you to have a graphing calculator because it's weird decimal, you would need to know logs. So can you just see if you remember this? Rewrite this as a log. Write small because we're going to cover this whole backside of the quiz with notes. I like to draw an arrow with these just to say this changes to a different form. And that would be log base 5 of 8 is equal to x. Raise your hand if you had that one right. Awesome. All right, next step is to change its base. Do you get its base right this second? Is base 5. But a lot of calculators can't handle that. Like some calculators are smart enough to just go log base 5 of 8 and you're done and you just hit enter and it gives you the answer. But a lot of the older calculators, and even if you have a newer calculator, you need to know this, you need to be able to change this to base 10 because then the calculator can handle it because the log button means base 10. Okay, so how do you get this to be base 10? Another way to say it is, how can you enter it in the computer just directly? Sorry, the calculator just directly? Does anybody remember this one? Usually it's a small group, so I'm going to just ask it that way. Think you remember what to type? You got it. And what you just did is, I like to think of it as you put a line through there like that, and it kind of helps you remember that it's log 8 over log 5. And what you just did is you changed that from log base 5 to, wait a minute, these don't have bases, but that means they do have a base. What base is it? Base 10. All right, so that's how you do a base change. Any questions on that one? All right, now this is a weird little just add-on, but do you get this? It actually be log base E and it would also work? It could be any base. It's just that log base E is, there's a button on your calculator for that. Log base 10, there's a button on your calculator for that. But technically, this could be log base 2.3. Log base 2.3. So this is a base change formula, and it works for any base. All right, the bigger the base, the smaller the answer. So if I asked you for like log base 2 of 8, I'll give you this example. See if this jogs some memories for you. Log base 2 of 8, you should be able to calculate in your head. Don't say it. Write this down, and I just said don't say it. Write this down, and then try to change it so that the 8 has a different base, and it'll make it so much easier. And what you should have done in your head is go, yeah, that's 2 to the third, and then the answer is 3. Raise your hand if you knew that one. Okay, good. If you forgot that one, you need to get those back in your head. So many little things to know about logs. None of them are super hard, but there's a lot of little rules. All right, how about this one? Even if I wrote it this way, log base 2 of 2 to the third, that 3 could go somewhere else in the log. How many of you guys remembered that it was to go in the front like that? Yes, several of you did. Okay, in case you forgot that, let me show you why that works. Look, we know the answer is 3, right? And what's that equal to? 1. So then it's 3 times 1. So the answer is still 3. Okay. All right, next thing you need to know about logs is how to condense them. If I have log base 2 of x plus log base 2 of 4 equals, let's say, 10, you will never solve a log problem unless you get it down to just one log on each side. Sometimes there isn't even one on each side, but you get it down to one log or you can't solve them. So that needs to be condensed. It's a very large plus sign. I'm going to change that because I see some people looking up here like, what's going on? Hopefully these are helping you to bring back how to do this stuff. If you didn't have this one in your head, if you're just looking at it going, I don't know what to do, if I were you, I'd write it down and then try to write the answer with me as just one log. Log base 2 of something equals 10. Luke, what do you think? Has to do with the 4 and the x, because these are both log base 2s. No ideas? It's all right. Just put 4x here in the argument spot. Get what just happened there? I just condensed these two logs. I'm leaning a lot on what you learned last year. You did learn this last year. We had whole tests on it. I know it's been a long time, but we made the two argument spots, this and this, go together, and we condensed it down into one log. Now, why is that even good? I said at the beginning of this whole unit that the key, the secret to this whole unit is whenever you get stuck, you just rewrite it. So try rewriting that one now. What do you mean rewrite? Well, it's a log, so get it out of logs. If it wasn't a log, you'd make it into a log. So it's all about putting in or taking it out of log form. What's the other form called? Log form versus exponential form. All right. So I'm doing this day because I knew that you'd need to review a lot of this stuff, because I can't just assume, oh yeah, they've got everything of logs down, because there's so many little pieces. All right, did you say 2 to the 10th is equal to 4x? And why is that good? Because now x is almost alone. How do you finish it, Mr. H? Ooh, look at him being all fancy. Instead of saying divided by 4, he's saying divided by 2 squared. I like it. I like it a lot. Because then you could really say x is equal to 2 to the what? I like it. That was smart. Okay. Now, I'm going to give you another one like that. Let's see if you can handle this. Log, notice, no base, of x plus log of 7 is equal to log of 21. I'll pause for a moment while you give this one a try. So it's actually easier if you know one little property of logs. Okay, Ella, what do you think? First step. All right, so log 7x, log 21. Next, oh, question? I get how that worked? Those two go together because they're the same base. And then we have just one log on each side. You know what to do? You are correct. Now, you do not have to technically remove them. It actually will save you time to just say that has to equal that. If the bases are the same, then the answer is already there. All right, so then x equals 3. Okay, now one little catch on this one. Imagine for a moment that I had come down to this. Log base 10, but I don't have to write the base, of x squared is equal to log, oh wait a minute, squared, no, it's not, that's not a good one. My bad. To the third is equal to log of negative 27. There we go. Let's say you came out with this after you did some work to like get it down to one log on each side. People sometimes just happily plot along and say, so x to the third is negative 27 and x is therefore negative 3. But it's wrong for two reasons. Why can't I take this, which I know, this is a new problem, completely new problem. I'm not saying it's the same as another problem. I'm just saying if the problem were like this, Why is there a problem with my problem? What can't be negative? Very good. And if I solved it down, I got x equals negative 3, because you said x to the third is negative 27. At that moment, you could have noticed it too, because when you got this answer, that's also impossible. Why? Because you can't put a negative in the argument right here, this argument. That can't be negative either. So you had 2 chances to catch that this problem is flawed. So there's just no solution. So that brings up domain. What are you allowed to have here and here? Let's make them letters then. Log base A of B is equal to C. Well, first of all, I could ask you to rewrite it. If I had you rewrite it, it would be solved for what? Yeah, right now it's solved for what? C. Do you get off with just a simple rewrite? I can have this solved for B. A to the C equals B. And then B is solved, and then you say it, there's 3 words. B is solved what? In terms of, there it is, those are the 3 words. B is solved in terms of A and C. Whichever one's alone, that's what's solved. B is solved in terms of whatever's over here, A and C. Okay, now, what can C be? Complete freedom, all real numbers. Anything can be the C. Why? Because it's just an exponent. Can exponents be negative? Sure, exponents can be negative, they can be decimals, they can be positive, they can be whole numbers, they can be anything. But A and B have rules. Do you remember what the domain, as in the rules, for what you can put in? All right, this one is, I like the natural numbers thing, but the problem is, you were trying to add on and other stuff, yes. So can this be the natural numbers? Absolutely, natural numbers would work. But it also could be between 0 and 1. So how do you include that? This is a simpler way to say it. Everything positive, that's true, an easy way to say it, but how do you write that in a math class and get credit for it? Yes, this would work. No, wait, can't be equal to. You were really close. B is greater than 0. Can't be equal to 0. 0 is not allowed there. Okay, what's another way to say it? 0 to infinity. Can it be 0? No, so parentheses. Okay, that's the domain of the B spot. That's these A, B, and C are just randomly chosen letters. That's called the argument spot. So that's the domain of the argument. Either one of those would be fine. But the domain of the base is just a little more complicated. You can't just say this. Why can't you just say that? Because there's one other little thing. Can't be 1. Maybe some of you didn't know that, but it's true. The base cannot be 1. Why can't that number be 1? Because it would lead to weird things like this. Log base 1 of 5 is x. Well, then try rewriting that. 1 to the x equals 5. Try to make that work. You can't. 1 to the something can't be 5. Yes? Can it be 0? And it cannot be 0. You are correct. So I was saying it was like this, with the parenthesis on the 0, except it also can't be 1. So how do you write that? Don't say this, because then you're saying it can't be a decimal, like 0.6. It can. Hint, I'll give it to you on a number line. I think you'll like it better there. So here's 0. Here's 1. You get that it can't be 0, and it can't be 1, but it can be between those two, and it can go forever that way. The reason I like number lines is because they're visual, and people, I think, are better at seeing the answer when I write it that way. It's basically bigger than 0, but it can't be 1. Could you have written that in interval? Sure, you could. All right, so what kind of questions lead themselves to that? Well, do you get if you have log base 3 of x plus 7, what's the domain of this function? Well, normally I would have said that this can be anything from, as long as it's bigger than 0, right? So then set x plus 7 is greater than 0. And you solve it. Try that one. I've been talking a lot. Need you to do some problems. So when is that bigger than 0? When x is bigger than negative 7. Okay. What if I put something a little more complicated in there? When I said equals 0, now I'm not asking the domain. I'm just asking to solve it. Solve. I'm having a hard time, so what should I do? I'm like, I don't know what to do. Always default to try a what? What's this? The thing you always go to when you're really stuck on logs. Rewrite it. So you go 3 to the 0 equals x squared. Oh, that's pretty easy. 3 to the 0 is 1 equals x squared. So what's x got to be? 1. Now, some people are going to go, but x can't be negative 1. But it's going to get squared. So x can be negative 1 in this case. X can be 1 and negative 1 because it's going to get squared. I know some of you feel like that's a trap. It has to be only 1. Because it's getting squared, negative 1's also a legal answer. So this, when I square root both sides, 1 is equal to absolute value of x. So x equals 1, x equals negative 1. They both work because of the squared. Okay, next thing. I'm going really fast, I know, but I'm covering everything that you have to know at this point. We have covered it all already. But I know it's been a long time. You had quite a few days off. That, you should know what it generally looks like as a graph. Sketch it. Hint, a log is like a tree that's been blown over in the wind. Here's my tree blown over in the wind, because we never have a standing up tree and call it a log, but if it blows over, it's laying on the ground, you can say, look at that log over there, and everybody understand. All right, so that's kind of what they look like. Now, how sharp is that turn? It all depends on how big this number is. The bigger that number is, the sharper the turn is. So it actually looks a lot sharper than what I drew. Answer would be much better like that. How would you ever know that? XY chart's your best friend in graphing. Everybody right now make an XY chart and find at least 2 places on this graph. At least 2 points. If you know it's a curve like this, 2 points isn't great because, 2 points defines a straight line. But if you kind of know how the curve looks, 2 points probably is good enough. Give me 1 point. What? Okay, that's not a point. 1 is a number. 1 comma 0, that's a point. Excellent, right there. Now I definitely need 1 more point. Yes? Excellent. When you put in a 7 right there, you get log base 7 of 7, which is 1. 7, 1. Over 7 up 1. See why I think it's more like the black one than I think it's more like the green one? The green one is not 7 comma 1. Know what I'm saying? So that green one was just a rough idea of what logs kind of look like. The black one's much more accurate. What if you needed 1 more point? Well, I would go with 49 right here. Why? Because then what's the answer? 2. So 49 comma 2. Holy crap, that's way off where your graph would normally be. So it's a little bit too big of numbers. One more that works for some people, I hope you can handle this, is 7 to the negative 1. What? You want to put in 7 to the negative 1? Yeah, because that's just the same as 1/7. Do you get what I'm saying? 1/7 goes in for x, and then it works really nice. What's 1/7? Negative 1. And watch where it is on the graph. Over 1/7, down 1. So I'll put since I was going with red dot themes, like that. And now all 3 dots are matching up. Yay. Okay. So if I asked you to graph this, you should be able to give me general idea what the graph looks like. More specific idea, 3 points. Everybody find 3 points on this graph without my help. I'll pause for a second while you give that one a try. All right, I'm going to put in -4 to challenge you. Now some of you are going to be like, but you can't do that. But I can. Because it tells me something. It tells you the asymptote. If you make this equal to 0, you have found the exact line that you can't be on. How does that help? Because then I know that x equals -4, which is over this way. This asymptote here is really important with that log. It'll go right up to it, but it can't touch it. Why? Because then you get 0 here in the argument, and we don't want a 0 there. So it's actually a pretty good space to find. All right, that's not a point, but it's the asymptote. That'd help. All right, dice of destiny. Row 3, person 3. The pew, sir.
So I did -3, correct?
-3. It feels wrong because some of you are thinking you can't put negatives there. But the total is still going to stay positive, so he's okay. Because you ended up with a 1 in the argument, and you guys remember that deal? If you won the argument, you get nothing. 0. Very good. -3, 0, that's this spot right here. I got 1 point. Can you do another one for me? -1 goes in here, and then I end up with what? What is this part, though? 4 plus the -1 makes 3, so that's log base 3 of 3, and you were correct when you said you got 1. So -1, 1 is apparently by that spot right there. And then if I wanted 1 more point, how about we get 1 more bigger number? Yes? 5. If I put in a 5 here, I get 5 plus 4 makes 9. Log base 3 of 9, that's going to work nicely, because then that's really 3 squared. And then 3 squared means that this is a 2 for an answer. So I'm going to put in a 5, I'm going to get a 2, and then that's over 5 and up 2. My blue line started to kind of go out of control there. It started going back down. So I wasn't actually that far off with my crazy blue line. All right, get out the surgical eraser. There they are. There. Okay. Is that everything? Believe it or not, it's still not even close. All right, you have to know so many little things. Here's another one. Logs, if you rewrite them, they're still equal. So if I do a rewrite on this and I go 2 to the y is equal to x, and you graph both of them, they'd be in the same place. I want you to think about that for a second. It's the same thing. You just rewrote it. You didn't change it to a completely different graph. You just rewrote it in a different form. But now what if I switched x and y around? Then I'd be making the what? The inverse. Is the inverse in the exact same place as the other one? No. It's a reflection across the line what? Y equals x. So here is an example. And here's where log base 2 of x would be. And then what would the other one that's like it, where I solve this for x and y flip-flop, and it's y equals 2 to the x. Oh, look at that. Y equals 2 to the x. That's like this. And do you get that those are a reflection across the line y equals x? One of them's a log, the one that looks like a tree blown over in the wind. That one's the log. And this one, I should say y equals, and this one's y equals this one, where I flipped x and y, reversed them, and then solved it. And then that was 2 to the x. Okay. Whew, so much to know. Now what if I add 7 here? Where does this log go? Up 7. What if I put a parenthesis around that? Now it's not moving up 7 anymore. Left 7. Okay. What if I take this one and add 7? That all moved up 7. Okay. And then what if I put a plus 7 up with the x? Left 7. Okay. Is that it? Basically one thing left. Try to stay with me here, and then the rest of the time you have to take this quiz. All right, the last thing is expanding something. It's like this was the answer to one of those condensed questions. Expand it out so it's at least 2 logs. Well, we know what base they have to be. If the first one was log base 2, the other ones have to be log base 2. And another one, he said at least 2. Okay. And then I'm processing this, and I'm like, oh, divide. That's right, they're divided, and that means something. That means that the logs are subtracted. Minus, yes. Okay. And then what should I put? Log base 2 of what? X squared, and this one's y. And that's really close to right, but it's not right. It's close to right. What's not right about it? It's just on a technicality, but that's all it takes to lose 5% on a test. To expand something all the way, this has to move to the front. It will take up a little more room. Not much. I get how that's like a, that's kind of a technicality, but I'm telling you about it, and you'll practice it on this quiz you're about to have in a second. So to expand it all the way, take any powers off and move them out to the front. So let's try one of those where you don't get any help. Log, no base, of 2x over 3 squared. Expand that as much as possible. As in, make it into a whole bunch of logs. Log base 2 of this, log base 3 of that. No, wait, they're all base 10. If it's a base 10, you do not have to write 10 in, but from my experience, that usually is a question where it's going to be all about the base. So whenever they don't have a base, I would stop and rewrite it with a base, because that becomes like the key thing. Because when we test you on it and we don't put a base there, we're trying to see, do they know that that's the base? And then you'll have to use that base to get the right answer. Okay. Did you say log? Log. And did you notice there was a way to make it 3 logs? Raise your hand if you got 3 logs out of it. Awesome. Okay, if you're like, I only see 2 logs, it's probably because you thought it was log 2x and log 3 squared. And then you thought, I'm going to be extra smart and move that 2 down in front. But wait a minute, that was a divide I was doing, so therefore it's a subtract. And then you thought, I'll be extra smart and move this 2 down in front. That is good, but that's not the right answer, because I just said you could make it into 3 logs. How? WG. Oh, yes, you could. That splits into 2 logs. Log base 10, I'm not going to write the base, so it's just log 2 plus log x. minus 2 log 3. And I would never mark it wrong if you put in the base, because from my experience, if the base isn't there, it usually becomes a big deal. And I'll show you one like that in a second. Yes?
You don't have to. Could you put that log base times 2 plus log base back?
It's a good question. Because of how this worked out, you are right, this wouldn't have mattered. But if I was subtracting two things, do you get how it would have mattered? So yes, it's a good idea to throw those parentheses in there. Because if I had had the two things here, you can't just randomly put a negative on one of the two. So that's a very good point. All right. Don't have to have them in this case, but if it had been a subtract of two things, you would want the parentheses. Okay. Almost done. I'll just see if you caught what I just said. 10 to the power of log 3. This is the rapid fire round where you're supposed to be able to just go, oh, the answer's 6. Boom. What is the answer? 3. Why? Because as soon as I write in the base that's missing, you'll go, oh, the base is the same, so the answer's already there. Know what I'm talking about? Okay, here's another one. Rapid fire. If you're like, why does that work? Let me show you. If I say equals x, because this is a exponent, and if I rewrite it as a log, I say it's got a base 10, and then I jump to the other side, because that's how you do rewrites. And then I jump back here. And look, I got log base 10 on both sides, x equals 3. That's how the answer is 3. You don't have to be able to prove that for me. You just have to be able to know this pattern. If those two are the same, that's the answer. So there's the last thing, finally. ln e to the 4th. You take the advice I've been giving you. You should be able to go, boom, the answer is this. Say it if you know it. 4, very good. Because ln is the same as log base e. And I suggested you rewrite that as a log base with its base, because if it doesn't have the base, it's all about the base. These are the same. There's the answer. Okay. Rapid fire round. What's the answer? Why? Because you won the argument, you get 0. You're right. How about this one? What's the answer? 7. Why? Because this whole thing, what's that equal to? 1. 1 times 7 is 7. All right. How about this one? 27. The base is the same. The answer is already there. That. Okay. Now that's going to get too icky. I'll just keep it simple. Oh, I didn't mean that. Dang it. Log 10. Oh, yeah. Oh, shoot. It doesn't work. Sorry. This will work. Log 16 over log 4. Did anybody figure out that that's exactly the same as log base 4 of 16? And therefore the answer's, it's because 16 is 4 to the, yes. This turns into log base 4 of 4 squared, and those are the same, so the answer's 2. And if you're like, why did this turn into that? I don't get that. It's that base change formula. These were both base 10s, and it's just like it started as that in the first place. That you can change it this way, you can change it the other way. Okay, that's a lot. But now you need the whole rest of the time. Everybody, flip this over.
Get out of here, bro.
Listen to me. And good luck. A lot of these are super easy. Here's some stumpers near the end. You can leave it like that. Like on that very first one where you get like 2 to the 5th, you can leave it. I don't want you to have to use a calculator, so I know some of you got it in your head, but you can leave it. All right, for those that are at home and you're wondering what the heck are they doing right now, I'm going to post a worksheet that we did today as a PDF, and if you are absent today, you should do that at home and bring it back to me. And that worksheet is called exponential / log check-in. And that's the homework for today, so that I can wrap up the video. I'll pause for a second to find that. Okay, so it's going to take longer to finish this quiz than I pictured, and because I gave you more help at the beginning than I pictured, but that's okay. I'm going to let you take it home and finish it at home. You may not get help from other people. That would be cheating. This is just counting as homework, and I totally get there's a couple hard ones on here, but don't ask your friends how to do them. That would be cheating. Okay, do your best on your own. And the only homework I want you to look up on the board, see that sheet? That's the assignment. It's on page 9 of your homework. You're just going to do the first problem on that page and the last problem on that page. That's it. First problem on the page, last problem on the page. You're done. 2 questions. Because this theoretically, this worksheet you have right now, is supposed to be finished in class. I gave you too much help at the beginning. So you'll have to take it home to finish it and just do 2 questions of homework. First and last problem off the first page of the homework. This kind of seafoamy green color. And that's all I have for you for today. That's 8.2, day 1.